students. In yesterday class, we have discussed the complex numbers objective. During applications of geometry, we have discussed. So here, the formula we had yesterday, area of triangle depends upon the z comma I z comma z plus I z. That is 1 by 2 modulus of z square, and area of triangle z comma I z comma z minus I z is 3 by 2 into modulus of z square, and z comma omega z comma z plus omega z area is root 3 by 4 modulus of z square. Depends upon this formula, we should discuss about these sums. Let us complete the worked examples. Later we can calculate these sums. Worked example 15. Let us finish the worked example 15, 16, 17, 18. Later we can do these sums. Worked examples 15, 16, 17, 18 and level 2 classwork 17, level 1 homework 36, level 1 classwork 38. Let us do the sums. Worked example 15. The triangle formed by the points represented by z comma I z comma z plus I z. Let A is equal to z, B is equal to I z, C is equal to z plus I z. The vertices of ABC can be represented as z comma I z comma z plus I z. Here z meaning x plus iy. You can indicate within brackets x comma y. Iz is equal to ix plus I square by I square becomes minus 1. So it is minus y. I square becomes minus 1. So it is minus y. Iz is equal to, this can be written as minus y comma x. Indication of geometrical concept. First of all, you should write only real number, later imaginary number. So minus 1 y comma x. This is B. So A, this is vertex A is x comma y. Vertex B is minus y comma x. And vertex C is z plus I z. So what is z here? X plus iy plus I z means here, like this you can write minus y plus ix. That is equal to x minus y within the brackets plus I into x plus y. So C is equal to, you can write according to geometry, x minus y comma x plus y. Now draw the triangle here ABC. Right here A x comma y and B minus y comma x, and C x minus y comma x plus y. Now AB distance, AB is equal to root of x2 minus x1 whole square plus y2 minus y whole square concept. I am doing here AB square. AB square is equal to x minus of minus y whole square, so x plus y whole square plus y minus x whole square. You can understand this one as y plus x whole square plus y minus x whole square. So a plus b whole square into a minus b whole square formula 2 into a square plus b square. So it is 2 into x square plus y square. Now bc square. Bc square is equal to here x minus y plus y. So simply x square. Next x plus y minus x. So it is simply y square. BC square completed. Now write CA square. X minus y minus x whole square. So it is y square plus x plus y minus y whole square. It is x square. Add these two values. You can get here 2 into x square plus y square. So you you can write here as BC square plus CA square. Therefore, AB square can be written as BC square plus CA square. Here x square plus y square and x square plus y square both are equal, and proved the formula AB square equal to BC square plus CA square. So the common letter B here, AB square is hypotenuse. So C is right angle triangle. Angle C is 90 degrees. This is common letter here. It is called as right angle isosceles triangle. So triangle ABC. Triangle ABC is a right angle isosceles triangle. Triangle ABC is right angle isosceles triangle. So 15 sum completed. Let us going to discuss about 16th question. This is somewhat applicable, important question. Sixteenth one. If modulus of Z1 is equal to modulus of Z2 equal to modulus of Z3 is equal to 1 and Z1 plus Z2 plus Z3 is equal to 0, then area of triangle whose vertices are Z1, Z2, Z3. Condition you can write. Condition is modulus of Z1 plus Z2 plus Z3. It's okay. Condition of Z1 plus Z2 plus Z3 equal to 0, comma, modulus of Z1 is equal to 1 and modulus of Z2 is equal to also 1 and modulus of Z3 is equal to also 1. Try to understand according to diagram. The concept is, this is an equilateral triangle. Put right here A Z1, here B Z2 and C Z3. Right here O. Using the concept centroid, so OG I am writing according to what vector method. OG is equal to Z1 plus Z2 plus Z3, Z1 plus Z2 plus Z3 whole by 3. So O meaning here origin. So of course simply G write. If G is equal to 0, that means G is equal to origin. If G is equal to origin, you can write here Z1 plus Z2 plus Z3 is equal to 0. If G is equal to origin, I have taken if circumcenter S is equal to origin. If circumcenter S is equal to origin, then you can write here this is modulus of Z1 because OA is equal to here given OA is equal to OB is equal to OC concept or SA is equal to SB is equal to SC concept. So what is SA meaning? Distance between the circumcenter and vertices. All are equal. So use that here OZ1. So OZ1 meaning here simply mod OA. So OA is nothing but OZ1. OA is equal to OZ1 like this. That is a modulus of OZ1 that is equal to simply Z1 that is equal to 1. In the similar way, given as modulus of Z2 is equal to 1 and modulus of Z3 is equal to 1. So like this. OB is equal to 1, modulus Z1. This is modulus Z2 equal to 1 and this is modulus Z3 equal to 1. Depends upon the concept of equilateral triangle here. Centroid is origin and circumcenter is also origin. Whenever circumcenter and origin are both are equal, the triangle is nothing but equilateral triangle. Therefore, triangle ABC is equilateral triangle. Triangle ABC is an equilateral triangle. So whenever it is an equilateral triangle, we know that every angle is 60 degrees. Every angle is 60 degrees. This is 60 degrees full angle, that is BAC. So according to property, POC is equal to 120 degrees. BOC is equal to 120 degrees. The property we know that if it is here alpha, the angle made at the circumcenter is 2 alpha. Right here this is 120. Put here this is O, this is B, this is C. So using cosine rule we can write here. Using cosine rule. Using cosine rule, BC square is equal to OB square plus OC square minus 2OB into OC into cos of angle BOC. So using the formula A square is equal to B square plus A square minus 2B cos capital A. That implies OB square, meaning here you can write what is the opposite of A. It is nothing but small a. That is modulus of Z2 minus Z3, distance between 2 points. Here you can write here AC square is equal to OB square, meaning itself is a modulus of Z2 whole square plus OC square, meaning is modulus of Z3 whole square minus 2 into here modulus of Z2 into modulus of Z3 into cos 120 degrees. That implies A square. So side of triangle you are getting. This is 1 plus 1 minus 2 into 1 into cos 120 value minus 1 by 2. So 2 get cancelled, 1 plus 1 becomes 3. So A square is equal to 3. Whenever triangle is equilateral, we need to calculate area of equitriangle. Area of equilateral triangle formula root 3 by 4 A square. Root 3 by 4 A square. So that is equal to here root 3 by 4 into 3. You can write as 3 root 3 by 4. 3 root 3 by 4 is the area of triangle. Now, worked example 17 depends upon the formula. Worked example 17. If the area of triangle in the arched plane formed with a complex number minus z, ij. So minus z, ij, z minus ij. Minus z is given. Maybe formula is wrong or right. You should verify. Z, ij, z minus ij. Minus z, ij, z minus ij. Then modulus z he is asking. Let us see the old material. Maybe the formula minus z, ij, z minus ij may be correct. In our material it is wrong. The formula just I have previously 1 by 3 by 2 modulus of z square in old material given that minus z only, students, not z. In our material you should correct the formula area of triangle. Area of triangle formed by vertices. Area of triangle formed by vertices minus z. First of all, minus z comma ij comma z minus ij. Minus z comma ij comma z minus ij is 3 by 2 into modulus of z square. So now worked example 17. Minus z comma ij comma z minus ij is 600 square centimeters. And what is the modulus of z? So that implies you write 3 by 2 into modulus of z square. 3 by 2 into modulus of z square is equal to 600. 3 will be dividing 200 times. So modulus of z square is equal to 400. Modulus of z square is equal to 400. Then we know that modulus z is equal to root of 400. So modulus z is equal to 20. Modulus z is equal to 20. Now let us see the IIT JEE mains question. Worked example 18. In each and every material you will face such question. Worked example 18. Worked example 18. If the area of triangle on the arched plane, if Z1, Z2 are roots of Z square plus AZ plus B is equal to 0, given quadratic equation given as Z square plus AZ plus B is equal to 0, and Z1 comma Z2 comma are the vertices of an equilateral triangle, then A square minus 3B. We have a property Z1 plus Z2 plus Z3 is equal to 0. So O plus Z1 plus Z2 plus Z3 is equal to 0. So Z1 plus Z2 is equal to minus A. Using the property, if it is an equilateral triangle, we can use Z1 square plus Z2 square plus Z3 square. Yesterday we said that Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Equilateral triangle property. Here Z1 comma Z2 and origin making Z1 comma Z2 and origin making an equilateral triangle. Draw like this. This is O, this is Z1 and this is Z2. Origin Z1 comma Z2 making an equilateral triangle. Let us write the formula. The formula is Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Whenever Z1 comma Z2 comma Z3 are equilateral, Z1 Z2 Z3 are vertices of an equilateral triangle, we can say that the formula Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Now here let Z3 is equal to origin 0. Whenever Z3 is equal to origin, you substitute here 0 square plus Z1 square plus Z2 square. Right here 0 square plus Z1 square plus Z2 square. So Z1 square plus Z2 square is equal to simply Z1 Z2. Because whenever Z3 is there, then you can substitute the value 0, you will be getting 0. So Z1 square plus Z2 square is equal to Z1 Z2 you got. Now that implies using the formula of A square plus B square, we can write the formula A plus B whole square minus 2AB. So right here Z1 plus Z2 whole square minus 2Z1 Z2. Z1 plus Z2 whole square minus 2Z1 Z2 is equal to Z1 Z2. That implies Z1 plus Z2 is equal to here sum of roots. So minus A whole square minus 2 into this is B is equal to B. That implies the relation is A square minus 2B is equal to B. So A square is equal to 3B. This is the relation. This is the ISB question in objective concept. And JEE mains, previous JEE mains also. Depends upon these application of geometry of complex number formulae. We can use level 2 class. We can see the sums level 2 class work 17 and level 1 homework 36 lines. 3 sums are there. Let us open the page. Level 2 classwork. 17th question. It is page number 26. Page number 26, level 2 classwork, 17th question. In an arced plane O, P, Q represent the origin Z and Z plus IZ respectively, then angle OPQ. Angle OPQ you need to calculate. Put here P, put here O, put here Q. Z plus is discussing with us. OPQ represents origin Z and Z plus IZ. O meaning itself is origin 0, 0. O meaning is 0, 0. So Z, P meaning Z, Q meaning Z plus IZ. So P is equal to Z. So Z is equal to, it is nothing but X plus I by. Next to P, Q. Q is equal to Z plus IZ. Q is equal to Z plus IZ. So multiply here, IZ becomes Ix minus Y. ix minus y. So here x plus iy plus ix minus y, that is equal to x minus y plus I taken common, it is x plus y. So q you can write as according to coordinates x minus y comma x plus y. R is input here, O0 comma 0. P is equal to minus y comma x, because ix minus y becomes first real part we should write minus y comma x. Q is equal to x minus y comma x plus y. Now let us going to discuss about the product of slopes concept. If product of slopes is equal to -1, then the angle is equal to 90 degrees between the two straight lines. So now slope of, we should discuss about the angle POQ. No, angle OPQ. Angle OPQ. So slope of OP into slope of PQ, let us discuss and verifying the option. Slope of OP into slope of PQ. Slope of OP meaning x minus 0 by minus y minus 0. So x by minus y into slope of OQ here, PQ here, x plus y minus x becomes y. By x minus y plus y, it is x. X and x get cancelled, y and y get cancelled. The product of slopes is equal to -1. Therefore, angle OPQ is equal to 90 degrees. Here he given the answer as third option, pi by 2. Now level 2, level 1 homework 36. Level 1 homework 36. Page number 42. Page 42. Level 1 homework 36, page 42. The area of triangle with vertices z comma iz comma, area of triangle delta is equal to, formed by the complex number z comma iz comma z plus iz is 1 by 2 modulus of z square. The formula 1 by 2 modulus of z square given as 50. So modulus of z square we got 100. So modulus z is equal to 10. That's all. Now level 1 classwork 38 bit. Level 1 classwork 38 bit, page number 20, page number 21. Page 21. Area of triangle formed by z comma omega z comma z plus omega z comma delta, and writing as the formula √3 by 4 into modulus of z square, where z comma omega comma z comma, area of triangle formed by z comma omega z comma z plus omega z is √3 by 4 modulus of z square. That implies he given the answer as √3 by 4 into modulus of z square is equal to 4 by √3. That implies modulus of z square is equal to 4 4 the 16 by 9. Now he is asking that modulus of z, so it is 4 by 3. 38, second option. He given as fourth option. Let us verify the formula. Area of the triangle formed by z comma omega z comma z plus omega z is exactly √3 by 4 modulus of z square. Now he given √3 by 4 modulus of z square is equal to 4 by √3. This is not 9 students, this is simply 3. So 16 by 3 is modulus of z square. So modulus of z is equal to 4 by √3. Now the sums depends upon applications of geometry. Small exams are completed, depends upon the small formulae. Now let us going to discuss about the geometrical applications in complex numbers. Applications of geometrical all concepts. Simply for line we have discussed. Hereafter let us going to discuss about the theory of the complex number for circle, parabola, ellipse, hyperbola and everything. Today class, the formula, the concept is locus of a complex number. This is the main heading. Locus of a complex number. Locus of a complex number. Good. After completion. Locus of complex number. So in locus, in first year 1B, we have discussed the locus chapter. Depends upon the locus, we have entered into straight lines, pair of straight lines, 3D geometry, and now in second year you have entered into the concept of complete locus is circles, system of circle, parabola, ellipse, hyperbola, everything. So entire geometry depends upon complex numbers. The topic is nothing but discussion of locus using complex number. So let us write the formula and verify. First, an equation of straight line. Write the formula, an equation of straight line. An equation of straight line passing through. An equation of straight line passing through 2 points. Passing through 2 points A Z1 and B Z2. Capital A Z1 and B Z2 is. This is a formula Z minus Z1 by Z minus Z1 by Z2 minus Z1 is equal to same concept. Use the conjugate complex number Z bar minus Z1 bar by Z2 bar minus Z1 bar. It is nothing but collinearity concept. Whenever 3 or more points lie on the same line, the points are said to be collinear. If the points are collinear, we can say that simply the all points lie on a same straight line. We need to calculate the equation of straight line using the collinear concept. Or using the area of triangle is equal to 0 like that also we can calculate. So an equation of straight line passing through 2 points Z1, Z2 is. Here you can write Z1, Z1 bar. Determinant of Z1, Z1 bar, Z2, Z2 bar 1. Here Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1 is equal to 0. Area of triangle using the complex numbers and its conjugate is equal to 0. Next, in this 2 methods are there. Parametric form of a straight line is also there. Parametric form of straight line. In the straight line concept, we can say 2 or 3 methods. First method is general equation of straight line ax plus b plus c equal to 0 or lx plus my plus n is equal to 0. Next one, parametric equation of symmetric form, everything we have discussed. Depends upon symmetric form x minus x1 by cos theta is equal to y minus y by sin theta is equal to some constant r. Depends upon that one, we have calculated x is equal to x1 plus r minus r cos theta and y is equal to y plus r minus r cos theta. It is called as parametric equation of straight line. And equation of straight line passing through 2 points, that is passing through 2 vectors. We said that r bar is equal to 1 minus t into a bar plus tb bar. Otherwise r bar is equal to a bar plus tb bar, where an equation of straight line passing through a point and parallel to another vector. Like that, using parametric points, here also we have an equation that r bar is equal to, the r bar means you should not consider here vector, because this is a complex number. We write simply this is z. Z is equal to t z1. So ab plus 1 minus t into b like this. A into b bar. Some constant into vector plus 1 minus t into, that is a constant to be another vector. Like this, you remember like this. Z is equal to t z1 plus 1 minus t into z2 is the parametric form of straight line passing through the 2 points a z1, z2, where t belongs to real number. T is any real number. Now write general equation of straight line. General equation of straight line. Let us calculate using the general equation of straight line, which is in the form of Lx plus Ny plus N. Let, of course, we can think Ax plus B plus C equal to 0 also, but here the letters are used in the way of A and B. That is why I am taking let the equation in Cartesian coordinate system in coordinate geometry. Let the equation of straight line. Let the equation of straight line is Lx plus My plus N is equal to 0. Lx plus My plus N is equal to 0. We know that it's keep aside. Z is equal to x plus Iy. Z is equal to x plus Iy. There only you write z bar is equal to x minus Iy. So a complex number and its conjugate we have taken. Now add both z plus z bar, you will be getting as like this 2x. Right, like this, x is equal to z plus z bar by 2. X is equal to z plus z bar by 2. Comma now z minus z bar becomes 2Iy. Z minus z bar becomes 2Iy because x plus Iy minus x plus Iy. It is 2Iy. Now y I am writing as z minus z bar by 2I. Y is equal to with I you multiply. So I into like this you write I into z minus z bar whole by minus 2. So y you can write as minus I into, take minus common. So I into you can write here as z bar minus z bar minus z by 2. Keep aside. Now the values whatever we got now, instead of x and instead of y, sub in this line, you can get the equation of straight line in complex form. Sub in 1. So L into z plus z bar by 2. L into z plus z bar by 2 plus m into here I into you write Im and write Im into z bar minus z bar minus z by 2 plus m is equal to 0. That implies take to LCM. So Lz plus Lz bar plus Lz bar plus Imz bar minus Imz plus 2n is equal to 0. 2n is nothing but a constant. That implies now Lz plus Imz minus Imz. Z take common. Z taken common, that implies Z into, right like this, L minus Im plus Z bar taken common, it becomes L plus Im. L plus Im plus 2n is equal to 0. Now, depends upon the line equation. Let this is A. Now, let L plus Im. So it is a complex number, simply I am thinking as A. Whenever it is A, L minus Im becomes, it is a complex number, is nothing but minus A bar. That implies, not minus A, but it is A bar. So you can write here A z bar plus A bar z. A z bar plus A bar z plus B is equal to 0. Is the equation of straight line in general form. Is the equation of straight line in general form. Az bar plus A bar z plus B is equal to 0 is the, yes, A bar z he given first. A bar z plus Az bar plus B is equal to 0 is the equation of straight line in general form. Next one, let us going to discuss about the slopes of the lines. slopes of the lines. Put side heading slope of lines. In complex plane. Complex plane is nothing but arced plane which you have discussed in IIT. Now, if A first formula, if A Z1 comma B Z2, A Z1 comma B Z2 are two complex numbers, 2 points you write. 2 points that implies slope of AB. Slope of AB, it can be written as mu is equal to, of course you said here, Z1 minus Z2 by Z1 bar minus Z2 bar, you can say easily Z1 minus Z2 by Z1 bar minus Z2 bar. And another formula, let us write slope of line AZ bar plus A bar Z. So A bar Z plus AZ bar plus B is equal to 0 is the notation here minus A by A bar. First of all, you should write AZ bar. Just previously I said that x plus I by x minus I by model, L plus IM and L minus IM model. So minus coef of x by coef of I concept, you can write here minus A by A bar is the slope of the complex number in general form, where A is non-zero and B is a real number. Of course, it's okay. Now, third formula you write, if mu means here slope of the complex line, mu1 comma mu2 are slopes, mu1 comma mu2 are slopes of two straight lines, that is complex straight lines in complex plane. Mu1 comma mu2 are two straight lines in complex plane. Mu1 comma mu2 are two straight lines in complex plane. And if mu1 is equal to mu2, then two lines are said to be parallel. Two lines are said to be parallel. Third one, if mu1 into mu2 is equal to minus 1, of course, in general geometry, the concept of complex numbers is also same concept, but here the slope indicates with the letter mu1 and slope indicates with another line is mu2. If mu1 mu2 is equal to minus 1, then the lines are said to be perpendicular or mutually orthogonal. The lines are said to be perpendicular. Now we are in the concept of complex number objective, complex planes, applications of geometry. Depends upon complex plane slope. Now let us going to discuss about angle between two lines. Angle between two lines. Angle between two lines. Of course, the angle is depends upon slope concept. Here, argument theta. So theta is equal to tan inverse y by x is the angle between the two complex numbers, where x is equal to r cos theta and y is equal to r sin theta concept. So here two lines are there. General lines are complex lines. We can calculate using the lines as if A is equal to A comma B comma C comma Z of right like this. If A Z1 B Z2 C Z3, A Z1, B Z2, C Z3, D Z4. Here there are 4 points. A, B, C, D are 4 points. A Z1, B Z2, C Z3, D Z4 are 4 points in argand plane. If angle between 4 points in complex plane or argand plane, we say complex plane or argand plane. If AB comma CD are two lines, AB comma CD are two lines, then angle between AB comma CD. Here these two lines are said to be intersecting lines. Put here A. This is Z1. Z1 is the complex point. B Z2. Draw like this. This is C. So this is Z3 and this is D. This is Z4. Intersecting lines forms 4 angles. Two opposite angles are equal. Vertically opposite angles are equal here. AB and CD. So angle theta is mentioned as argument. Argument of it depends upon slope. This is Z1 minus Z2 by, of course, slope concept. Y2 minus Y1 by X2 minus X1 model. Here Z1 minus Z2 by Z3 minus Z4 is nothing but argument of whatever the complex number, difference of complex number is there, is nothing but angle between the two intersecting straight lines. Now, reflection of lines. Reflection of lines, some mistake is there. It is not right in our material. Okay, length of perpendicular formula. Write the formula length of perpendicular. Length of perpendicular from a point to a given line. Length of perpendicular from a point to given line. If Z1 is any point in the complex plane I am discussing with you. If Z1 is any point in complex plane or argand plane, if Z1 is any point in the complex plane, if A bar Z plus AZ bar plus B is equal to 0 is the equation of line. A bar Z plus AZ bar plus B equal to 0 is the equation of line. Then length of perpendicular, of course in complex plane, this is a complex plane, this is PZ1. This is a line A bar Z plus AZ bar plus B is equal to 0. We should calculate here the perpendicular distance of length of perpendicular from PZ1 to this line. AZ perpendicular line, then the formula is length is equal to, if AZ bar, A bar Z plus AZ bar plus B is equal to 0 is the equation of this line. Then perpendicular distance or length of perpendicular distance from Z1 is equal to A bar, simply you can substitute here, A bar Z1 plus AZ1 bar plus B by 2A. This A is a scalar, that too mod A, because length is positive always. Now we have discussed about the lines concept. Let us going to discuss about the circle concept. Depends upon the complex plane. Let us going to discuss about the circle. In IPE, in DOS there are complex number. We have discussed regarding the equation of circle in the complex plane. Example, I think. Now let us going to discuss about the equation of circle having center 0, 0, comma radius r and having center h, comma k and radius r also we discuss now. The equation of circle having center, now we write the equation of circle having center z0 here, meaning it's a complex number having center z0 and radius r, having center z0 is of course you can understand this one as h comma k, right, like this. So h plus ik is a complex number having center z0 and radius r is modulus of z minus z0 is equal to r. Students, this is general notation. Calculating the equation of circle and center and radius depends upon this complex number. Better to convert the complex number into Cartesian coordinates and calculate in the old method only. Better method. This is not better way. Of course, we can write the formula simply. We are writing z minus z0, modulus of z minus z0 is equal to r. You can say here. You can try to understand this is x plus iy and this is x0 plus iy0. Taken x minus x0 whole square plus y minus y0 whole square is equal to r square is nothing but the equation of circle having center x0 comma y0 and radius r. Now modulus of z minus z0 r, this is another method. This is another method. Z bar like this. Z bar minus z0, z bar minus z0, z bar minus z0 bar z plus z0 z bar. Z bar minus z0 z bar minus z0 bar z plus z0 z bar. Z0 bar plus Z0 bar minus r square is equal to 0. R minus r square z bar minus z0 z bar minus z0 z bar plus z0 bar minus r square equal to 0. Next one, this is the first formula. Next, try to understand this one. Equation of circle having a comma b end points of diameter or extremities of diameter. Let the a is x1 comma y1, b is x2 comma y2. In complex, in general geometry we have discussed using the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. In the similar way, you can write here equation of circle. Here z1 means x1 plus iy1, z2 meaning x2 plus iy2. So equation of circle having a z1 comma b z2. Equation of circle having a z1 comma b z2 as endpoints of diameter. Endpoints are extremities. Endpoints or extremities of diameter is z1 minus z1 bar into z bar minus z2 bar plus z minus z2 bar z minus z2 z minus z2 into z bar minus z1 bar equal to 0. Or another formula is there. Simply this are formula. but better to calculate using the geometrical method only correct. Modulus of z minus z1 whole square plus mod, this is correct way students. Modulus of z minus z1 whole square plus modulus of z minus z2 whole square is equal to modulus of z1 minus z2 whole square. Otherwise, whenever the complex number is given directly, then you can write using the x1 by 1 x2 by 2 and the points of diameter concept is better way. Let us going to discuss about equation of circle, center and radius of circle. The general equation, I said the proof. The general equation of circle in the complex plane. The general equation of circle in the complex plane is z bar in the complex plane is z bar plus a bar plus a bar z plus b is equal to 0. Z bar plus a bar z plus a z bar plus b is equal to 0, where b is a real number and the center of the circle. B belongs to capital R, so B is any real number. Center of such circle is equal to formula simply minus A, and radius. Radius is equal to, here students you can understand A meaning not only simply it is also a complex number. This circle is depends upon complex number. In the complex plane we are using the circle, whatever the circle we have lent in Cartesian coordinate system, that Cartesian coordinate system converted into the complex number system. So now center is equal to minus A and radius is equal to root of A bar minus B. Here root of A bar minus B is the radius. Same concept of radius is equal to root of z square plus f square minus c concept. Okay students, regarding circles we have discussed. Whatever the conditions are there depends upon circles, depends upon parabola, hyperbola and angles between two circles, like that everything we can discuss in next class.